Hi everyone, welcome back to Chemical Engineering Statistics. Today we will discuss further on the ANOVA model. Suppose we have A different levels of a single factor that we wish to compare. So here we can see that we have A treatment level, A level of single factor. So the single factor sometimes is called as treatment. The response for each of the A treatments is a random variables. So this is all the random variables which are the response of each treatment at particular observation. The observed data would appear as shown on the table, say in the form of Yij, that represent the jth observation taken under treatment I. So Y12 is the second observation taken under the first treatment level. In ANOVA model, every point can be written as sum of this equation. Yij, each response equal to mu plus tau I plus epsilon ij, with I from 1 to A and j from 1 to n. Yij is a random variable denoting the ijth observation, while mu is the overall mean and the value is common to all treatments. This is the overall means. Tau ij is the parameter associated with the ith treatment called the treatment effect. And epsilon ij is the random error component. So in general, the ANOVA model, also known as the effect model. In ANOVA model, we will compare quantitatively the tau ij and the epsilon ij. Which one has greatest significance to the total variance of the experiments? If the tau I has greater significance than epsilon ij, that means the experimental factor significantly affect the response, and vice versa. To do the ANOVA, first we can show that the total sum of square is shown in this formula. The total sum of square is the total variability in the data. So total sum of square is the overall variability of the data. The total sum of square can be partitioned into sum of square of treatment and sum of square of error. The sum of square of treatment can be denoted as this formula, and the sum of square of error can be denoted by this formula. If the sum of square is divided by the appropriate degree of freedom, we will have the mean square, and the mean square value is equal to variance. If we look at the ANOVA table, the variation between treatment is called as the sum of square of treatment. The degree of freedom is A minus 1. If we divide the sum of square of treatment by A minus 1, we got the mean square of treatment. The variation between or within treatment is called the error, and the sum of square is the sum of square of error. The degree of freedom is n minus a, the capital N. The mean square is ms error. In ANOVA, we conduct the f-test to compare the two variants. So here we can calculate the f0 equal to ms treatment divided by ms error. We can compare the calculated f value with the critical f value. The critical f value can be obtained from the f table at particular significance level and at particular degree of freedoms. If the calculated f is more than the critical f, we can conclude that it is fine to reject the null hypothesis. The null hypothesis in ANOVA is treatment 1 equal to treatment 2 equal to treatment 3 equal to treatment A. So the null hypothesis basically stated that there are no changes or no significant effect from the treatment. So if we reject the null hypothesis, means that there are significant effect of the treatment on the response. In addition to the f value, we can also use the p-value approach to draw conclusion from the ANOVA table. And the p-value approach is somehow more general, more widely used than the f-critical value. That's all for today. See you in the next video.